Welcome to Section 3, Creating the Player Character. Creating the Player Character's Code, Part 1, Basic Character Setup. In this video, we're going to set up our player inputs, set up our player health, and our sprinting state. First, let's go to the top left, under Edit, select Project Settings. Under the Engine category, go to Input, and we will be adding in some action and axis mappings. Let's start with action mappings by selecting the plus symbol to add one. An action mapping is code that will fire off when a key is pressed or released for this action. We will have 5 action mappings. The first one will be named Jump. The second one will be named Fire. The third one will be named Sprint. The fourth one will be named Pause Game. And the last one will be named Interact. For Jump, we will be adding the spacebar key. For Fire, we will be using the left mouse button. For Sprint, we will be using the left shift key. For Pause Game, we will have 2 key inputs, so we can add another for that action by selecting the plus symbol next to the action. We will be using the escape key and the backspace key. For Interact, we will be using the E key. Now we will start adding some axis mappings. This works the same way as the action mappings, except it is constantly being fired and provides a float value, which will represent that value when it is pressed and 0 when it is not pressed. We will have 4 axis mappings. The first one will be named Move Forward. The second one will be named Move Right. The third one will be named Look Up. And the last one will be named Turn. Any inputs using the binding method are case sensitive. For Move Forward, we will have 4 key values. For the last 2, we will have them as -1 values when they are pressed instead of +1. This is to let us know to do the opposite of what this button is supposed to be pressing. So in the case of Move Forward with the W key or the up arrow key, which will be our 2 inputs for +1, our reverse of that will be the backwards movement, which is down arrow and the S key. For Move Right, we will also be using 4 inputs. And just like the Move Forward axis mapping, we will have 2 that are -1. For Move Right, we will be using the D key and the right arrow for +1. For negative values, we will be using the A key and the left arrow. For Look Up, we will be using the mouse input, which will be mouse Y. And for Turn, we will be using mouse X. Now let's close Project Settings and navigate to our base character inside of our C++ classes folders. Open it by double-clicking on Base Character. This will be our base class to build off of when we need a general kind of code to fire, such as damaging any players or NPCs nearby and such. The virtual keyword under Begin Plays function allows us to inherit this function down to subclasses so that they can use their own version of this function, and the override keyword so this function cannot continue to be inherited anymore past this class, blocking any subclasses from inheriting it, but it becomes cancelled out by the virtual keyword, which takes priority. It's good practice to have the override keyword on a virtual function if it's being inherited down, which helps the programmer notify themselves that this is a virtual function. We specify whether or not something is public, private, or protected if it has the keyword with the colon after it, and then any functions or variables below that are within that category of public, private, or protected. In the case of base character, we will not be using the setup player input component or tick functions, so we will be removing these. Be sure to save any work that you've done within the Visual Studio Editor by going to the top left where it says Save All, or save base character.h, which is just the file that you're currently in. Now let's go into our source file, which is the .cpp file, and clean up our other functions such as the setup player input components definition and the tick functions definition. Let's save our changes and jump back into our base character. Here we have added 2 functions, onDeath_implementation, and we've added 3 variables, two floats, which are the current health and max health variables, and a boolean, which is our state of whether or not we are sprinting for this character. The function onDeath has the uFunction macro above it to signal that we want specific features to be within Blueprint. In this case, we have added the Blueprint native event, which allows us to use this as a sort of virtual function that works within Blueprint. Because it is Blueprint native event, we must repeat this function, but with the virtual keyword and implementation after the function name. This will be our C++ version of the code within this function, while the onDeath will not have a definition, but that will be our Blueprint version of the code. The keyword pureVirtual allows this virtual function to not have a definition when it is declared. It is also important to note the comma afterwards. We must define it in any subclasses, or else the compiler will not accept it though. The keyword BlueprintCallable allows us to actually call this function in Blueprint if need be. And the keyword category is required so that this function is organized somewhere within the Blueprint code library. In the case of current health, we will not be needing to use it within Blueprint, so we don't add a uProperty macro above it. For max health, we will be editing it within Blueprint and within our editor default values panel of the Blueprint. The edit defaults only allows us to edit this value in the editor, but only in the defaults menu of said Blueprint, but not on any instances that have spawned. The Blueprint read-write allows us to use this variable within Blueprint code for both getting and setting the value. For our sprinting boolean, we have a visible anywhere keyword, which allows us to see the variable within the editor, both in the defaults menu and on instances, but we cannot edit the value within the editor. Blueprint read-only allows us to get this variable but not set it within Blueprint, while also being able to set the value within C++. This is typically used to allow a certain amount of control over some values that we wouldn't want edited by another teammate or team member that works only in Blueprint. Under the public category, we have our constructor, which is the same name as our class, except with a parameters above it, so that this code will fire when the object is created. Then we created 3 more functions as getters and setters for our variables. Since they are protected, we cannot access them publicly from any other classes, so we have these sort of functions to be able to access them in some capacity. For our getCurrentHealth and getMaxHealth, we have the keyword BlueprintPure. This allows this function to be used for both complex calculations and for getting accurate values such as for floats. But you cannot change values within the function because of the way it is designed, that for more advanced programmers that we won't be getting into. In the setCurrentHealth, we have a parameter which is a type float value named newHealth, and we are setting our current health to equal newHealth. Let's jump into our source file and add some code to our constructor. Here we've gone into our constructor's function, which is a function that gets fired when the object is created in memory, and this is typically where you put your base default values and where you would create your components and such when the object is created. Here we have a simple if statement. The keyword if starts the statement and using the parentheses asks whether or not this is true or false. If this statement is true, then we would enter the curly braces and execute the code within the braces. If it is false, then we would skip over the curly braces and continue on. Here we are checking if our current health is not equal to our max health. If it isn't, then update our current health to be equal to our max health. Now that we've done all of our changes, let's compile our code. Go to Build and rebuild the name of our project. This may change for other projects. In the output log, you'll see whether or not the code is compiling when it results within a succeeded, failed, or skipped line. In our case, the build succeeded where nothing failed and nothing was skipped. So we can jump back into Unreal Engine and see our code has been edited by right-clicking on base character and creating a Blueprint class base character. But we can also create a C++ class derived from this, and we will create one now. We will name this player character. In our player character, you may notice there really isn't any code. This is because it inherits from base character, and thus inherits any functions or constructor values that have been set within it. We will set up our constructor for this class by copying and pasting the name of the class and then adding parentheses to it. One thing to note is that you must have the constructor within the public category. This is very important when creating an object within code. You must always have access to the constructor in case you wanted to add some extra variables or values to it when it is constructed. The reason why we have to specify that it is public is because by default everything is private. Let's add a definition for our constructor by copying and pasting the code within to the source file. Copy and paste the name of the constructor function, go to our source file, paste it, and add 2 colons, and then paste it again, and then add parentheses, and 2 curly braces. Now we have created our constructor, and defined it. And in the next video, we will be creating the player character's code, part 2, setting up our player character.